the one which you have done in the previous class, that you just get it again. Have you written it? This is what I expect you to do. Okay, students, as I directly started the class just because I want it to be continuous, right? What we have done in the last class, okay, that I want you to get through, right? What is that you have learned in the last class is about the Mendelian inheritance. So John Gregor Mendel, okay, that was the first word I used. He was the first person to bring about the laws of inheritance. He started the word using the word of inheritance or the concept of inheritance. So inheritance is the condition in which the characters are transferred from parents to the offsprings. Those are called the hereditary characters, right? So he was the first person to start this. And what he analyzed was, by his certain experiments he analyzed something. What is that? By working on pea plants, by hybridizing them, he got certain conclusions. He published them, all the results, in one local magazine, right? But that magazine, which was of limited circulation, could not reach everyone. Even other scientists who are there all over the world could not read this, because there was one issue, because he had written the whole, whatever he has done experiment, all of them in a tabulated column form, tabular forms, which was not able to understood. It was not understood by anybody during then. That's the reason why his whatever he has done the work, it got wasted in his lifetime. Okay. Now, why I am giving you this example, right? This is the major problem happened with Mendel. Even you think about yourself, whenever you are writing your answers, I have observed you people writing from top to the bottom without leaving margin, without giving gap between the paragraphs, and if you write illegibly, nobody can understand that. So the same problem happened with Mendel, although he had done a greatest work, but it remained unrecognized during his lifetime. So what happened was, he died without getting recognized. His timing was, his duration, he lived from 1822 to 1884. That was the time when Mendel lived. So Mendel lived from 1822 to 1884. Okay? That was his duration. In his whole of life, whatever he has done, that went in vain. It was not utilized. It was not understood by anybody else. This was the issue happened with Mendel. But later, when he was no more, after 30 years of his death, 3 scientists rediscovered Mendel's work. So, who rediscovered Mendelism? Rediscoverers. First one, I hope you heard their names. One is Hugo de Vries, is from Holland. Then second person, Karl Correns from Germany. Then the third person was Schermack from Austria. These were the 3 people who rediscovered Mendelian work. That is very late, not when he was living, right? Only after 30 years of his death, the work was recognized, rediscovered. And really they were surprised to see whatever Mendel has given in the form of laws, whatever he has given the experiments, they were all so accurate with pea plants, right? The same experiment when they conducted, they were the same to same result how Mendel got. Therefore, they were really appreciating what Mendel did, and the whole world started appreciating Mendel, and that's the reason why all the work whatever was given to Mendel was named as Mendelism. Right? See, again and again, Mendel's work I am appreciating because everybody in the whole world, everybody appreciates him because he did it just for his curiosity. Not to, by birth only becoming scientist is my aim of life. No. So later he was recognized as a great geneticist. He was the father of, he is still today, his work is considered an excellent work. So that is a Mendelian inheritance. Then afterwards, Mendel's whole work was rewritten by Hugo de Vries, and it was given in the name of certain terms called certain laws of Mendel. Actually, Mendel did not make laws. It was later rewritten by Hugo de Vries and it was called as Mendelian laws. So we have two Mendelian laws. First law of Mendel is law of segregation. Second law of Mendel is law of independent assortment. That I will explain you after this. Okay. So this is again a small history of Mendel I gave you. So every time when we start with Mendelism, you should study what was the greatness about Mendel, why his work is till today accepted as the topmost work in the genetics part. Right. Now coming to the, so these three names they will ask you for 2 marks. Write a note on or name those scientists who rediscovered Mendelism. You are supposed to write these 3 names. Okay. Now let's now move on to next part. I told you yesterday as one homework. I hope you remember. What was that? I told you that what are the characters of Mendel, or the Mendelian inheritance is followed in some of the human traits. What are those traits which are following Mendelism, Mendelian inheritance, Mendelian laws? One I already gave you. What is the first law in Mendel's inheritance? What are the characters in humans? First character, we talked about the brown eyes that are dominating over blue eyes, which are not Indian eye colors. But what other example you can remember is, that is about the tongue rolling characters, because the tongue rollers are dominant over non-rollers. What do you mean by tongue rollers? Actually, our tongue has certain muscles, which is made up of muscles, right? Those who can roll the tongue like a pipe, like this, right? Like pipe, right? All of you try this, right? Tongue can be rolled not reverse way, like this, okay? It can be rolled like a pipe. That's called tongue rolling character. Tongue rollers are normally dominant. You can observe everybody in your house, ask them to roll their tongue in a tube-like fashion. If they roll, it is the dominant character. Many people are dominant like that. They all have tongue rolling character. But some of them cannot roll like me. I can't roll the tongue. I can't roll it. It is a non-rolling character. It is a recessive character. So that is also following Mendelian simple inheritance. First law of Mendel, one is dominant, one is recessive. That's the second character. Then the hexadactylity means having 6 fingers. One more finger will be there. This is the recessive character. Pentadactylity is the dominant character. Hexadactylity is the recessive character. Okay. Like this, one or some more characters you can study. So 1 or 2 I have already told you. That is, one is about the brown eye color and dominating over the blue eye color. It is the Western people. Second character is tongue rolling character. Tongue which can be rolled in a longitudinal way like a pipe, like this, right? Which is happening in those, they are all dominating, and those who cannot roll the tongue, they are all recessive. They are called non-rollers of tongue. That's a recessive character. Once the college starts, let us check in the whole class how many can roll the tongue, how many cannot roll the tongue. That's a simple experiment of Mendelism. Okay. Now, having this background, some more characters I will give you. What Mendel gave, right? So whatever I explained you, this one, whole characters of the Mendels, this is about the monohybrid cross I told you. Single character, one pair of contrasting characters are considering and crossing the plants, right? Now we talk about the second type of experiments done by him. We call this as dihybrid cross. What is the dihybrid cross? The cross between 2 pure breeding plants that differ in 2 pairs of contrasting characters, not one pair. One pair means like tall and dwarf. Red flowers, white flowers, one character. Now I am talking about those characters, 2 at a time you are taking, considering and identifying how are they inheriting, right? For this he made two plants pure breeding with two dominant characters, two recessive characters. So the parents what he considered were double dominant parent, double dominant referring to the character that is having two dominant features together, right? Then crossed it with the double recessive character. Okay. So now, what is the double dominant character in pea plant? You have to consider two dominant characters. So what was collected, what was done by him was first was the seed color and seed shape, right? They are the two characters of the same. Then what is the dominant character of seed shape is a smooth or round character. Round we can call it. Round and wrinkled we can call it. And or smooth and wrinkled also they call anyway you can write round and wrinkled, right? Round character is dominant over the wrinkled character. Second is the seed color, yellow color is dominant over the green colored seeds. So what is the double dominant parents P1 generations phenotype? Let's now consider the phenotype of parents. What is the double dominant character? One is the round and yellow seeds. So character I have taken is the seed character, this is seed. Crossed over to its recessive, double recessive character is the wrinkled and green character, green. Okay, these are both are seed characters only. It's a two character I am considering. Round is one character showing the shape. Then the color is yellow. Now, what can be the genotype? See here, whenever you are writing genotype, you have to be very careful. As I told you in monohybrid cross, one only you are considering, one pair. You are considering two pairs of contrasting features. What is the genotype of this round and yellow? Round for round, capital R you are considering. Then yellow you are considering capital Y. Right? Every character should be written in a diploid condition. Again and again I am stressing on this. That every time whenever you take a character, when you write its genotype of parent, they should be written two times. Right? Crossing with the double recessive character, small r, small y, small y. In some of the books they give capital S and small s also, that is smooth and wrinkled also given, or round and wrinkled also you can write it, right? So check it, whichever you feel easy you can write, right? Capital S, small s also you write, you can write it. But what happens so many times we write small s so big that it looks like a capital S, right? Therefore I want you to be very clear, I am giving you round and wrinkled, okay? Now, what are the gametes? G generation gametes. I told you gametes will be formed by reduction and division of the parents, right? So this will undergo reduction division, it becomes haploid for R, haploid for Y, R and Y together in one gamete. This is very important. While writing gametes, you should not separate them because one gamete only will carry all the characters in haploid condition. Means if it is the sperm or the pollen grain, it will contain R and Y in their haploid condition, single you should write. Then here you get R and Y in a single type. Single type, not one gamete. It's a single type. All will be having small r, this side. All will be having capital R, capital Y here. Okay. Now in F1 generation, these will undergo fertilization and get capital R, capital Y, small y. Right. This is the round and yellow. Or I told you after this I will give you with smooth yellow also we can write it. Right? Instead of the round and yellow, you can write smooth yellow also. But anyway, this is the F1 generation. This is the F1 generation. First one, whatever I have written, the genotype of F1. This is the phenotype of F1. This genotype, this is the phenotype. Now, you are going to self-pollinate the F1. On selfing of F1, what you get is the second character, F1 cross with F1. First you write this much. After writing this, I will erase and write the F1 on selfing. Okay? Write this. Okay. Hope you have written it. Now, this F1 we are going to take it. You have to write in a flowchart like fashion. like I am erasing, don't have to think that it is different, that is different. I am saying the continuation features, but I am not writing below this because there is no place, okay, no other way, right? Therefore, let me write once again the F1 on selfing in a dihybrid cross. So, next is F1 on selfing. What you will write? F1 cross with F1. Actually, F1 is a dihybrid now. This hybrid we call it as a dihybrid, not a monohybrid. Two characters you are considering. Two pairs of contrasting characters are considered. Now, what is the phenotype of F1? You already just now went through. Phenotype of F1 is they are round and yellow. Both F1 are round and yellow, so you are crossing round yellow. But these round yellow are heterozygous in nature, not the first parent. Parental genotypes when you are taken, we have taken it is pure breeding. Now these are heterozygous in nature, so this is not that round yellow, these are the hybrid round yellow. Therefore, the genotype must be, genotype will be capital R, small r, capital Y, small y. Always distinguish between both the alphabets. Don't write the same way of alphabets, okay? Then crossed with capital R, capital Y, small y. Okay? This is genotype of F1. Now, while producing gametes, very important thing is here the formation of gametes. Like already I told you that parents started with round and yellow and green, wrinkled and green, right? We started like that. Now, those genotypes, whatever were there in the gamete formation of parents, will not be the same here. What happens is, this is one pair of allele, this is another pair of allele. Okay? Each allele of an allelic pair combines or assorts independent with the another pair. Means this will be forming gamete with capital Y or with small y. Capital R and capital Y can be one type of gamete, or capital R has the equal possibility of combining with small y also, capital R, small y. Same is, small r may have can get independently assorting with small r and capital Y, or small r with small y. This is a very important thing in Mendelian inheritance. This is the second law of Mendel. We call this as law of independent assortment. So how do you state the law? In a dihybrid cross, when two pairs of contrasting characters are considered, during gamete formation of hybrids, each allele of an allelic pair inherits independently. That's it. Means this capital R inherit either with capital Y or small y, forming two gametes. Or small r, this is the pair of allele. This independently it will inherit, this independently it will inherit. That's the meaning of independent assortment. They are assorting. Then same as this side also, capital R, capital Y, capital R, small y, small r, capital Y, small r, small y. Whenever you are writing, you keep reading and talking, or you just loudly speak about it and write it, otherwise you will not get it. So these are the four types of gametes in from one parent, male gametes, these are the female gametes, or vice versa is true, right? Now, these you have to cross them in F2, right? The pollen grain having capital R, capital Y may fertilize the egg with either capital R, capital Y, capital R, small y, small r, capital Y, small r, small y. The same may this also, this also, this also. All of them they will have various possibilities of fertilizing with the other one to produce large number of F2 possibilities. So that F2 I will give you up to the time, till that time you just copy this, right? Copying is very important for me. This everything I want to be clear, I don't want to mix it up, because I have seen writing from top to bottom, you will not know where to start, where to end. So therefore this you finish, I will erase this and then start with the writing how these will get combined by drawing a Punnet's checkerboard. So I hope you are writing this. Okay. Now, okay, this is the law of independent assortment. Means how we stated in a dihybrid cross, when two pairs of alleles are considered, each allele of an allelic pair inherits independent of the other. Okay. Now let me write the F2 generation with the help of Punnet's checkerboard. We are representing with the help of Punnet's checkerboard. Very important is this. So what you will write first? Let me write all the gametes. Then we are going to fertilize. Show the fertilization. Capital R, capital Y, one gamete. Capital R, small y, one gamete. See, I am just showing you so big gap. So almost half of the page you write the checkerboard. Otherwise, this is going to be a big issue, and this will be your homework. Whatever you have written, I am writing. I want you to write the same way. Take a pic and send me. Right? So that I can understand that you are also trying to write. Instead of just reading whatever comes like a movie you are watching and forgetting. Don't want. You have to write this and completely F1, F2 full. Then checkerboard, then you should show me. Okay? Then second is, third one is capital small r, capital Y, small r, small y. These are the four gametes. Other side again, capital R, capital Y. Right? Capital R, small y. Small r, capital Y, small r, small y. Okay. So this is the capital R, capital Y. Okay. Then put the checkerboard. See, clearly take a pencil and scale. Write them thoroughly, properly. This is the how you are going to write the checkerboard. Okay. One side is the male gamete. These are the male gamete, this is the female gamete, downside, right? Now you are going to write the combination. First combination is capital R, capital R, capital Y, capital Y. This will be the round and yellow. First one is round yellow. Write full form. Therefore, make the big checkerboard. Don't draw very small checkerboards. Then you will have no place to write the phenotypes. Then you will write like small mustard seeds. Then nobody can see that. Write a huge big checkerboard so that you will not get any jam inside the checkerboard. Okay. Now next is capital R, capital R. You keep saying along with me. Capital R, and then capital Y, small y. Then what is this? This is round and, because capital Y is there, it is yellow only. See this. R and capital R is round, which is homozygous, but capital Y small is heterozygous. Next, capital R, small r, capital Y, capital Y. You can see here, capital R, small r, capital Y, capital Y. Always, I told you, mention Y properly. If you don't show the Y like this, small rounded structure here, you will not understand which Y is this. Right? This is a major problem happening in most of the students while writing in examination. They themselves will confuse with your alphabets. Therefore, don't do that. Write properly the Y. All these are whatever without any rounded thing I have drawn, it is a capital Y. Now this is capital R, capital R. Because of capital R, it is round. Okay? Because of capital Y, it is again yellow. Next is capital R, small r, capital Y, small y. Right? What is this then? This, because of capital R, it is again round. Because of capital Y, it is yellow. Round and yellow. Same thing. Now again, next point is here. Capital R, capital Y, small y. See, capital R, capital Y, small y. Whichever is capital, you should bring it first. Don't write small y, capital Y. That is the rules again. Right? This is again round and yellow. Right. Next is capital R. All of you try. All this like a maths it is. Here is a different thing. Here is small y, here is small y. So this is a new thing. Small y is formed, which was not there in the parents. This combination is not there. So it will be round, fine, but because of small y it is green in color. This is a new character. This is the indication that it has undergone independent assortment. The gametes, their alleles have undergone independent assortment. That's the reason why we are getting new combination like this, round and green. Parents never had round and green. Parents are either round and yellow or wrinkled and green. But there is a new combination form. This is called as a recombinant. Recombinant is whichever is not there in the parent, it is produced in the offspring. This is the first new recombinant formed. Right? Whenever you are writing, if you go wrong in writing these gametes only, then your checkerboard will be wrong totally. Now, what is the next one? Capital R, small r, then capital Y, small y. Again it is round and wrinkled. Sorry, round and yellow. See, capital R and capital Y is there. Next is capital R, small r. You can say capital R, small y. Remember this, capital R, small r. Because of capital R it is round, but because of small y it is green, isn't it? This you have to understand. Next is capital R, small r, capital Y. Check it. Capital Y. This is again round and yellow. Okay. Now, next is capital R, small r, capital Y, small y. Capital R, small r, capital Y, small y. Again it is round and yellow. Next is small r. See here, small r. This is small r, this is small r. Then capital Y. This is a new combination again. Small r refers to wrinkled seeds, right? This is a wrinkled seed with the yellow color. Again a new recombinant, right? Next is small r, capital Y, small y. How is this? Tell me. This is again wrinkled but yellow. Okay? Keep writing the last line. So what is the last line? Again you will write here capital R, small r, capital Y, small y. How is this? This is round and yellow. Next is capital R, small y, How is this? This is round and green. See, new character. This is a new character. Round and green is a new character. But what else? What else is new character? Wrinkled yellow is also a new character. This is another new character. Right? Now, these are again small r, capital Y, small y. How is this? This is again wrinkled and yellow. All are new characters. One more new character. Last one is small r, small y. Small r, small y. It is wrinkled and green. This is the parental combination, is total recessive. Check 1, 2, 3 are new character. This is one new character. This is also new character. This is also new character. Apart from that, there is another new character. This is new, this is new, this is new. So, these are the new recombinants saying that there must be an independent assortment of alleles that have happened during gamete formation. Write the checkerboard again, then I will give you calculations. Okay, now let's calculate how many are round yellow. Just calculate. This is round yellow. 1, 2, 3, 4, 5, 6, 7, 8, 9. You can see here, almost like you get it in one, what do we call it, as a right angle. So if you can say this, all, these are all round and yellow, right? How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So how many are round yellow here? There are 9. Round yellow are totally 9 in number. Okay. Now this is over. Now how many are round and green? 1, 2, 3. Or that's why I made 1 star, 1 star, 1 star to remember them. Otherwise you will feel mix everything, right? So 1, 2, 3 are round and green. They are 3 in number. Okay. Next, how many are wrinkled and yellow? 1, 2, 3. See, all these come like a right angle triangle like this. Okay. This 1, 2, 3, 1, 2, 3. These are totally 9, right? So wrinkled and yellow 1, 2, 3. You don't have to write the right angle, just I am saying it. Okay? It is a wrinkled and yellow are 3 totally. Then only 1 is wrinkled and green. Wrinkled, green, it is only 1. So apparently means phenotypically, how many are getting round 9, round yellow 9, round green 3, wrinkled yellow 3 and wrinkled green 1, right? This we call it the phenotypic ratio of F2 in a dihybrid cross. So what is that? It is the phenotypic ratio of F2 in a dihybrid cross is equal to 9:3:3:1. This is the dihybrid phenotypic ratio of F2 in the dihybrid cross. Okay, dihybrid phenotypic ratio in F2. Right? So this checkerboard I just showed you to understand this triangle. Don't write the triangles. Right? So what is the total combination I give you? How many are the parental combinations here? How many parents are there? We started with the first parents, P1 generation. We started with the round and yellow as the dominant parent, wrinkled green as the recessive parent. Right? Now tell me how many are the parental combinations? 1, 2, 3, 4, totally 9 are dominant parent, 1 is a recessive parent. So totally 10 are the parental combinations in this. But how many recombinants are there? You can see new characters which were not there in the parents. 1, 2, 3, round and green, 3 are there. Wrinkled yellow 1, 2, 3, totally 6 are the new recombinants. This formation of new recombinants indicate, or it is a proof that alleles during the F1 hybrid gamete formation might have undergone independent assortment. Otherwise you would have got all parental combinations only. But as you are getting new recombinants, it indicates there are new characters produced by the hybridization of alleles as they have segregated independently. They are undergone independently, not segregation, independently they have assorted, forming different types of gametes. Therefore, 9:3:3:1 ratio indicate the F2 phenotypic dihybrid ratio. Now we have to calculate the genotypic ratio. Till here, be perfect. It is 100% required, and this whole thing can carry 3 marks to you. Checkerboard with the phenotypic ratio is almost 3 mark in a 5 mark question. 2 mark is for P1, F1 and all in the explanation also. So whenever you are writing its explanation, you cannot write like a mathematic things. What you have to write? In P plants, say how to explain this. In P plants, the character of seed when it is considered, the round or the smooth seed coat character is dominant over the wrinkled seed coat. Right? In that either you can take round or smooth also. If you take smooth, you should take capital S and wrinkled small s. Right? Now, I said in a P plant, the seed character when it is considered, round charactered seed coat is dominant over wrinkled seed coat. And color of the seed coat when it is considered, the yellow color is dominant over the green colored seeds. This is the basic thing. Now, in dihybrid, 2 contrasting features are considered. Therefore, in this 2 characters of the seed coat are considered. One is the seed coat texture, another is seed coat color. Now, in dihybrid cross only, a double dominant plant is, or pure breeding double dominant plant is crossed with the pure breeding double recessive plant, right? Then when double dominant character is considered, here the two dominant characters are, one is round or the smooth seeds and the yellow. Smooth yellow or round yellow is dominant character. Then the double recessive character is wrinkled and grey. It's a double recessive character. When you consider the genotype, you should write capital R, capital R, capital Y as the genotype of P1, parental generation, for the round and yellow. What about the recessive character? Wrinkled and green. It is small r, small y. Wrinkled and green character. And when they produce gametes, because they are pure breeding, round and yellow produce single gamete with capital R, capital Y, and the wrinkled green produce small r, small y. During fertilization, they form the hybrids, which are round and yellow, because round is dominant over wrinkled, and then yellow is dominant over green. So you will have capital R, small r, capital Y, small y. Okay. Then F1 on selfie, you get this combination. Right? Write this and state the law. Okay. What is the next thing I told you? F1 you are taking, F1 hybrid is produced. That F1 you are going to allow it for cell pollination. And F1 dihybrids, when they are cell pollinated, then the parents are round and yellow hybrid. Take the genotype capital R, small r, capital Y, cross with the capital R, small r, capital Y, small y. Now, during gamete formation, it follows second law of Mendel. What is the second law of Mendel saying? Or it states that whenever two pairs of alleles are considered in a dihybrid cross, during gamete formation of hybrids, the two alleles of each pair independently assort. That's a second law. Therefore, you get 4 type of gametes in each combination. This 4, these 4. Now, they undergo fertilization in all probable combinations. You will have to write the F2 generation in a completely checkerboard form. This is a checkerboard. You have to write 16 totally squares with the gametes at the tip. Right? So, this checkerboard carries marks to you. Then you have to write big squares in each, so that genotype, phenotype, both you are writing in the same one. And don't write the cut short the phenotypes. Don't write R and Y here, because it is a phenotype. Therefore, ultimately we get 16 combinations. Out of 16, 9 are round and yellow, that are the parental dominant characters. 9 are there. Then 3 are new combinations, that is round and green. Other 3 are again new combinations, wrinkled yellow. And last is the recessive character, that is wrinkled and green. Therefore, you get the phenotypic ratio as round yellow 9, round green 3, wrinkled yellow 3, wrinkled green 1. There is a phenotypic ratio of F2 in a dihybrid process, 9:3:3:1. It's a very important thing for you to score well. It's like a mathematics thing. Like every step you will get marks, checkerboard you will get marks, explanation you will get marks. So don't anytime just guess, okay, somehow I'll write some checkerboard, I'll write. No. If you can't write the parents, you can't write about the children also. Right? If you write the wrong parents, then how to get this kind of children? Right? Therefore, you are supposed to consider the proper parental phenotype, genotype, F1 hybrids, and then F1 gametes, then the law, why they undergo independent assortment, then how do they combine during fertilization, then the checkerboard, right? So checkerboard will not come first, remember that. Therefore, just practicing checkerboard will not work, and just writing explanation will not work. Together they will fetch you marks, right? But practice this, write a big checkerboard. This is my basic request to you all students. You keep writing checkerboard, and as so many students are sending me whatever homework I am giving, they are writing and they are mailing me. Not just mailing, they are taking a pic and sending me. That's a really beautiful act of yours. That's really good thing for you and for your scoring also, because this chapter is considered to be little more technical chapter. Therefore, if you come out with this in a good way, you can do this, then you can really get a nice ranking. Not only in board, even in NEET, this will work very nicely. But you need to work hard for this. This checkerboard and this one, you have to understand thoroughly. Okay? Did you understand this phenotypic ratio? Okay. Now let me give you what is the genotypic ratio of this. Okay? So let us now study the genotypic ratio. Already I told you genotypic ratio is how many are homozygous, which allele is homozygous, which allele is heterozygous. Okay? First let me consider the first one. This is the first one. What I am saying is both the alleles are homozygous. Capital R, capital R, capital Y, capital Y. How many are there in this? There is only one. Right? There is only one having two homozygous dominant alleles. This is one. This is one. Right. Next is this combination. It is homozygous for the round character, heterozygous for yellow character. That is capital R, capital R, capital Y, small y. How many are there this combination? One is this, another one is here. Just check. Right? I am writing, those who are finishing, I am just writing them. Otherwise you will again and again count the same thing. Right? But better once you have made them circle, you remove them. Previous you are considered different way. You have to write another checkerboard and check this, how it is. Okay? I hope you understood. So this is the 1 and 2. These are homozygous for round and heterozygous for yellow. These are totally 2 in number. Next is this combination. What is this combination? Heterozygous for round, homozygous for yellow. How many are there? This is 1. This is 1. See, almost in the corners you get this and this. This and this. How many are there? 1 and 2. It is 2 here. Right? Next comes capital R, small r, capital Y, small y. Check it, how many are there? All in the diagonals you get it. 1, 2, 3, 4. All of them 1, 2, 3, 4. Heterozygous for both alleles. They are totally 4 in number. Understand thoroughly. Now, what is left? We have finished all. This is left. One is capital R, small y, small y. How many are there? Capital R, small y, only one is there. There is no other combination with this. So it is only one here. Okay? So this is also done. Now, capital R, small y. How many are there? This is one and this is another one. Right? This and this. Right? Therefore it is 2. Okay? That's done. Now coming to this. Small r, capital Y. How many are there? Small r, capital Y, nowhere. It is only one. Right? This is done. Then small r, capital Y, small y. How many are there? This is one and this is one. They are 2. Okay? Then last one is small r, small y. It is only one. That's it. So this is the genotypic ratio of F2. This is how I write it as a genotypic ratio. What is genotypic ratio now? We can see here 1 is to 2 is to 2 is to 4 is to 1 is to 2 is to 1 is to 2 is to 1. This is the genotypic ratio of F2 in a dihybrid cross, and at the end you count them. They should become 16 combinations. It should not be varying, right? So let's see, 1 plus 2 plus 2, 5 plus 4, 9, 10, 12, 13, 14, 15, 16. Totally it should be 16. Among these you just now find out how many are phenotypically round and yellow. This is genotypic ratio. Round and yellow, this is round yellow, right? And this is also round yellow. 4 plus 2 plus 2 plus 1. So 9 are round yellow, right? Phenotypic. See, at the end it is like confirmation test. These are round yellow. How many are there round yellow? You have got 9 here. Okay. Now round and green. Check it. This is round green. This is round green. This is the round and green. How many are there? 1, 2 plus 1, 3. It's correct. Right. Next is, this is the next combination, wrinkled and yellow. Wrinkled yellow. So these are wrinkled and yellow. How many are there? These are also 3 in number, right? 3, 2, this is 9, right? Last one is wrinkled green, it is only 1. So you can see 9:3:3:1 ratio confirmed for phenotype. This is the genotype, this is the phenotype. Together you have to consider. This will not come if you just look at the video, right? Apart from this, you have to work. Actually, there is an advantage for you. You can pause it, read again, find out where I am going right or wrong, then write it. Once you observe fully, don't just keep on copying, observe fully, try to write on your own. There is no time restriction right now, you have a lot of time only all the whole day, right? Sit and write the whole checkerboard and calculate the genotypic ratio, calculate the phenotypic ratio. This is the most important thing, and really start enjoying genetics after you understand Mendelian inheritance. Because it's like how you are writing mathematical numbers, no? Mathematical problems. That way, one after another, they are giving you good marks also, and you can score well also in this. Okay? So, you write this again. I'll leave it for some time, check it and write it. Now, let's continue with the dihybrid cross. I told you that dihybrid cross, you are taking 2 pairs of contrasting characters and you are going to cross the double dominant parent with the double recessive parent, right? You understood this. Now, 1 or 2 extra examples you take and write in the same way, right? What I told you in Mendelism, totally 7 characters he has explained. Take any 2 characters, then you work on it, or else some other examples which are given in your book or neat book or whatever, you can write it and write and show me how many new characters you are going to combine and give. But in examination you write only this character, but because this is the one which is given in your NCERT syllabus, okay? Therefore you have to take this example only. Otherwise you can do any other cross, means round and, the red and white flower along with tall and dwarf stem. You can take that also. But anyway, this combination is the one which is prescribed in your book. You have to write this only, right? Now, once you finish the dihybrid cross, genotypic ratio and phenotypic ratio of F2 in a Punnett checkerboard you have written. I hope so, right? So let me see. When you take the pick and send me, you have to write. Don't look at the board and okay, leave it, right? It's like working out the problems of genetics, right? Now, next thing is about dihybrid cross and its test cross, right? Already in monohybrid cross I told you, right? What is test cross? It is a type of back cross in which a hybrid is crossed back with its recessive parent and resulting in formation of dominant and recessive characters in 1:1 ratio. That was the monohybrid test cross. Now, let's talk about the dihybrid test cross. Okay, so this is very simple. The same way you have to write. Take a dihybrid, F1 dihybrid I am writing here, dihybrid cross with the recessive parent. Okay. Again we take the same example, round and green, or we can take, one more thing I would like to tell you. Sometimes the double dominant parent you can consider as smooth and yellow also I can take, right? Capital S, capital Y also I can take. With the other character, double recessive character. What is double recessive character? Recessive character is the wrinkled and green. Okay, you can take small s, small y, small y. But what's happening? I am observing the students are writing this S also in the same way. Therefore, I took the round one. But if you feel in some books they are given smooth also, some books they are given round also. Okay, you can write anything is fine. Okay. Now, keeping this as a background, let's consider here the F1 dihybrid crossed to its double recessive parent. It's a double recessive parent, right? Then what is the F1 dihybrid character? Already we have told In the previous example I solved and showed you what is a dihybrid character. F1 dihybrid phenotype I will write now. Means parental your things you already crossed. You are considering that F1 hybrid directly, right? I am not taking again P1. No, I am directly taking the F1 hybrid. Okay, take the F1 dihybrid. It is round and yellow, or we can now I will give you this as a smooth yellow. Okay, so that you will get an idea. Smooth, if you write, how it will be. Smooth is again the texture of the seed. What is the genotype of this hybrid? Genotype is capital S, capital S, capital Y, capital Y. It is a dominant. But I told you F1 it is. F1 hybrid is capital S, capital Y, small y. This is a dihybrid. Hybrid means you should get heterozygous combination. Parental combination, if they are pure breeding, it is smooth and yellow is capital S, capital S, capital Y, capital Y. But now I am writing the F1 hybrid. Hybrid character should be capital S, capital Y, small y. Smooth and yellow is this character. This is genotype. Cross it with the double recessive parent. What is the double recessive character? It is a wrinkled green character. You already know this. What is this genotype? Wrinkled. We have taken S now. Small s, small y, small y. Okay. Normally while writing gametes, I want you to write the gametes for this and get the answer. Okay. Because whenever you are getting this combination of hybrid combination, you will get law of independent assortment. Right? Write the gametes, write this cross also and give me the answer tomorrow. Right? I will not solve. If I keep on solving, what happens is you get used to it, just keep copying. Okay? Tomorrow I again will see how many of you will send me the answers. If you send me the answers, looking at that, I will solve how many are right, how many are wrong based on that. Okay? Write the gametes and write the gametes here, cross them, find the ratio. This is your homework today. Homework is whatever I have written that you are copying. Apart from that, dihybrid test cross with this combination, you write the F1 genotypes of the gametes, and this gamete, cross them and tell me the result of the F2. What is the next combination? What is the ratio of dihybrid test cross? What are the combinations? Okay, that will be your homework. Okay, I hope so. You will do it, and it will really give some work to your brain. Right? Work on this. Okay, fine. I'll keep this as it is, and then I want you to work on this. After finishing the dihybrid cross, okay, what next? You have learnt about the dihybrid cross, and the dihybrid cross is test cross, right? And I told you, you are going to show me. Now the next part left is how exactly many characters when you are considering, or other plants how they respond, whether they follow Mendelism or not, right? These actually were studied even by Mendel himself. He found that some other plants also, they were following up to a certain extent all the laws of Mendel, but afterward they showed certain deviations. Okay, those we are going to learn under the next heading, that is deviations from Mendelism. Deviations. Okay, so what are the deviations? First, one of the plant I will give you example, then I will tell you why it is showing deviation. The name example I am giving you, its name is Mirabilis jalapa. That's the name of the plant. So what is this plant? Mirabilis jalapa. Separately I am going to label them. Because underline them because it's a binomial nomenclature. Its common name is 4 o'clock plant. Okay. Now what is the speciality of this? 4 o'clock plant, we call it in a common language, because common English we call it because it will bloom in the evening time. After 4 o'clock it starts blooming. Even it is called as the evening jasmine or night jasmine. It will open in the evening. but it is not actually smelling. It is a perfume like flower like jasmine. The flower will be of this shape, then it will be, okay, and here is the calyx, and here are the petals. They have a crumpled corolla, right? This is a crumpled corolla, and this is the flower character. Their color, if I say, I hope you will get it. The color of these flowers are dark pink, that is bright pink. Some are red, some are white. Sometimes you get yellow also. There is a variation in its flower color. So this plant, 4 o'clock plant, shows certain deviations from Mendelism. That I will give you now. What is the deviation? If you understand, then I can define what is it. And its seeds, normally small seeds which are looking like pepper seeds. That you will get it then easily. Now, what is the characteristic of this 4 o'clock plant or Mirabilis jalapa? So first thing, parental generation, P1 generation, phenotype I will consider. Phenotype, pure breeding red flowered plants crossed with the white flowered plants. Okay, this is the first character, first phenotype. Then what about their genotype? Genotype is capital R for red flower, small r for the white flower. That is the normal character, you have already done it, like a monohybrid cross. Coming to the G generation or gametic generation, there will be single gamete from here, capital R, single gamete from here, small r. Okay, they undergo fertilization, produce capital R, small r as F1 hybrids genotype. See, always this is very important. You have to write the side headings properly. This is the genotype. How it looked? Actually, according to Mendel, whenever two pure breeding plants with the contrasting features are crossed, in F1 hybrids you get only dominant character expressed, not the recessive. Recessive gets suppressed. Here I told you this is dominant over this. Then what you expect? F1 should be red. But surprisingly he found that the F1 plant which is hybrid was showing dark red or pink flower character. This is not a new character. This is a red in its dilute form. It is called it can be taken as a pink or it's a dull red color. Now he explains that this is considered as the pink colored character is incompletely dominant over white. Red is fine, but white character it is not able to suppress completely. Therefore, you are showing a pink color. Pink color is not a altogether new color. It is the diluted red color. We call this as a pink. This condition in which dominant feature is unable to express completely is called incomplete dominance. Very important word is this. Incomplete dominance. This is what I want to tell you. First, that's why I gave you example. Dominance. What is incomplete dominance? Inability of a dominant character to express completely in F1 hybrids out of two contrasting characters. Right? This we call it as a pink. It is because it's pink because of incomplete dominance. This is incomplete dominance. Okay? Now, this pink color character, so what I told you, this capital R small r is a pink colored phenotype. Right? Now you take this F1 and self F1 on selfing. How was F1? F1 was pink, right? So what is the phenotype of F1 then? Phenotype of F1 is pink. You can see here, pink it is. Pink cross to pink. Because you are selfing F1 and F1 only. Right? Now, what is the genotype of this pink? Genotype is capital R, small r, and this is again capital R and small r because they are F1 hybrids. Now, what is the type of gamete? You already know law of segregation. You get two types of gametes here, capital R, small r. Here also capital R, small r. These are two combinations. Now, you put the checkerboard and identify in F2. F2 checkerboard, what I will write? One side capital R, one side small r. Another side again capital R and small r. Write the proper checkerboard because this will be carrying marks to you. Right? Don't mix up the things. Right? Checkerboard. Okay? Capital R, small r. Capital R, small r. one side male gametes, you have to follow this, how to write. One side female gamete this side. Now capital R combination will give you which character? This is the homozygous character. This will produce a red flower plants. Then capital R small r, this is producing pink character. Why? Because heterozygous condition. Heterozygous leads to pink color. Then again capital R small r, this is producing pink color of flowers. Then small r is producing white flowers. So in F2, in Punnett checkerboard you can see what is the ratio? The ratio of F2 is equal to 1 red to 2 pink to 1 white. This is 1:2:1. Both phenotypic and genotypic ratio is 1:2:1. That's why it is a deviation from Mendelism. So first deviation from Mendelism is showing incomplete dominance. Means the dominant character is unable to express completely. It is showing in between. It is not an in between character. Instead, it is a dull character of the dominant character. So what all I told? The plant what you have taken here is a 4 o'clock plant. It's called Mirabilis jalapa. Right? I retained it here. Mirabilis jalapa is called 4 o'clock plant because it is blooming in the afternoons, right? Almost in the evening time. That's 4 o'clock plus 4, 5 o'clock it will bloom. Therefore, its name is 4 o'clock plant. Now, take this Mirabilis plant with the variations in the flower color. Make one flower color red as a pure red by cell pollination, white pure breeding with cell pollination. Take both of them as the parents, red and white. Produce the F1. In F1, you get hybridized character, capital R, small r, will result in the red color in dull form, it is called the pink color. This is because of the incomplete dominance of red over white. Therefore, the name is the incomplete dominance. It is one of the deviation from Mendelian inheritance. Otherwise, Mendelian inheritance says that in F1, dominant character is expressed, but here it is not fully expressed. Therefore, it's called the incomplete dominance. Now take the F1 hybrids and self them. F1 and F1 are crossing, pink and pink are crossing. Check it. Then what is the genotype of F1? Capital R small r, capital R small r. Take the gametes, they will segregate because of the heterozygosity. Capital R 50%, small r 50%, again capital R 50%, capital small r 50%. Put the checkerboard, one side male gametes, one side female gametes. In the checkerboard, you have to write both phenotypes and genotypes. Capital R produce a homozygous character, therefore it will be red in color because there is no incomplete dominance when both are homozygous for red. Second is capital R and small r. You can see it's capital R, small r. This is producing pink flowers. Pink flowers because it is heterozygous. Heterozygosity in that character, in this kind of plant, it is showing incomplete dominance. Therefore, whenever you get capital R, small r, you are getting the dull red or pink color. Next again capital R small r, again pink color. Small r is producing white because it's the pure breeding white. So therefore the total ratio of F2 is 1 red to 2 pink to 1 white, 1:2:1. This is both phenotypic and genotypic ratio of F2 in Mirabilis jalapa plant, which shows incomplete dominance. This is a 5-mark question. It will come almost every alternate examination, board exam, it is, you are going to expect this question. Right? What are you have to write? First, what is the definition of incomplete dominance? What is the definition? The inability of the dominant character to express completely in F1 hybrids is called incomplete dominance. Next is example. With an illustration, you are going to explain it. Example, we are considering here is the 4 o'clock plant or Mirabilis jalapa plant. Now, what is the character? Red and white are crossing, getting pink in F1, and when you allow pink for selfing, you get 1 red to 2 pink to 1 white, 1:2:1, both phenotypic and genotypic ratio. In contrast with Mendelian monohybrid ratio, what is Mendelian monohybrid ratio in F2? It is 3:1, 3 dominant to 1 recessive. But here it is different, because of that only we call it as a deviation from Mendelism. This is one important characteristic of which is a deviation, and for examination point is very important. It's simple also to get full marks. Okay, I hope you will understand that. You will understand it, and I want you to write down including the complete genotypic and phenotypic ratio. Just copy it. I hope so you have done it. Let's now move on to next part. Another deviation I will give you. That's about the character called codominance. I will not do much in detail right now. Only when I will explain you, blood groups, I will explain you that in detail. So another deviation from Mendelism, it is second type. It is codominance. What is the meaning of codominance? When two contrasting features are considered in the parents, in hybrids both the alleles express equally, co-mix together, equally dominant character. That is called codominance. Example I will give you, it is not there anyway much mentioned in a book, but I will just explain you. One of the example is in cow. Cow skin color, the hair or the fur color, hair color of the cow, reddish color is dominant over white color. It's a hair color, right? So if you think of the reddish hair color, skin color in cow, okay? What happens is the red female or male, anything is okay, is crossed with the white. Red refers to the skin hair color this is red, this is white, okay? This is the skin color, right? Whenever these are crossed, means capital R and small r, small r. Capital R and small r are the gametes. Combine capital R, small r, you will have to get here either somewhat dull. Together you will have to get it. It is not incomplete dominance. This codominance. This is getting something called the roan color. This is a new color. What is roan? Just let me show with one color only. So imagine this is a red-haired cow. Red haired one, this is a white haired one, right? When they are crossed, in F1 I told you the hair color is roan. What is roan? Just imagine this is the body, skin, and the hair will be half red, right? And half white. This is, imagine this is the white color. Above each there will be the red color like this, like this, like this. This is called the roan color, which indicate it is a codominant character. Both are expressing, red also is expressing, white is also expressing. Therefore, it is called the codominance. What is the definition for codominance? It is the expression of both the contrasting features in hybrids equally in same dominance. Both are equally dominant. Then it is called a codominance. Among the two contrasting features in F1 hybrids, both will express equally. It is called the codominance. Another example is there. It's nothing but the AB blood groups in humans. Another example I am giving is AB blood group. What is it? I will tell you later. AB blood group is also an example for codominance. One example is skin color. Second example is AB blood group in human beings. Right? Now, keeping that in mind, I will explain you the further things. So, we have learnt incomplete dominance, we have learnt the codominance. So, before I go to the next unit, this actually completes Mendelism. I would like to give you something different now. That is some questions from board. Right? What are the questions to be are expected from this? Okay? Principles of Mendel, Mendelian principles or laws of Mendel. I will write some of the questions or explain you. You are going to write the answers. So first, 1 mark questions I will give you. What are 1 mark questions? They will ask you various terms given by Mendel, like what are alleles. So this you are going to write. What are the unit factors? Right? What is homozygosity? What is heterozygosity? Now one more thing is loci. Locus is the position on the chromosome where the gene is located. We call it the locus, or what is loci? It is the position of the particular gene on the chromosome. Like that is fixed. Apart from that, you will get what is mean by dominance. What is mean by recessive character, recessiveness. Next, what is phenotype? What is the genotype? Okay, these are certain characters you have to remember. They are all the Mendelian terms. Next, in 2 mark questions, all these are 1 mark questions. Same thing. Next, they will ask you about the Mendelian ratios. What are the ratios they are expecting? First one, Mendelian monohybrid F2 phenotypic ratio. What is the monohybrid phenotypic ratio of F2? It is equal to 3:1. 3 dominant is to 1 recessive. Then monohybrid F2 genotypic ratio. This is equal to 1:2:1. Very important, these ratios you remember. Then dihybrid F2 phenotypic ratio. What is the dihybrid phenotypic ratio of F2? This is 9:3:3:1. Right? That's a dihybrid phenotypic ratio. What is next? Dihybrid F2 genotypic ratio. How much is this? Genotypic ratio is equal to 1:2:4:1:2:1:2:1. This is a ratio. Calculate at the end, it should be 16. This is 5 plus 4, 9, 10, 11, 12, 13, 14, 15, 16. This is the ratio of dihybrid ratio of genotype in Mendelism. So apart from this, what next I will give you is other ratios. First is monohybrid test cross ratio. How much is monohybrid test cross ratio? Is equal to 1:1. Then dihybrid test cross ratio. This I told you to do it. This is a question mark. You are supposed to show me. Right? And then deviations. Incomplete dominance. Phenotypic ratio of F2 is 1:2:1. Genotypic ratio of F2 is 1:2:1. Right? All the ratios will be perfect. Then only you will expect some marks in this. This ratio will come only when you do the illustrations crosses. Okay? These questions you note it down. Write the answer. Each one you write allele definition, unit factor definition, homozygosity definition, heterozygosity, like that. Every word you write the definitions. All 1 mark questions. Very, very important questions, and not just important just because it is all the whole subject you are learned, so it is important. You are not learned subject, then all look same for you. Right? These ratios also how important because we have solved them. Okay? Now, next is about the 5 mark questions I will give you. These only can be made as 2 mark questions also. Right? Differentiate between homozygosity and heterozygosity. Differentiate between phenotype and genotype. Distinguish between dominance and recessive. Like that it can give you 2 mark questions also. What are the important 5 mark questions? First thing, simple. State first law of Mendel. This many students will get confused. In some of the books they are given first law as law of dominance. There is no law of dominance. Okay. So first law of Mendel means it is law of segregation or law of purity of gametes. This is the first law. First law of Mendel is law of segregation or law of purity of gametes. First they say state first law of Mendel and illustrate with the help of an example. This is the 5 mark question here. State first law of Mendel or state law of segregation and illustrate the same with an example. You have to take first talk about the first law. It says that whenever a hybrid produces gametes, the two alleles, because of heterozygosity, they segregate or they separate. That's the law. Example. According to Mendel, all the laws of Mendel are followed by only pea plant. So, considering a pea plant, according to Mendelian, considering a pea plant, tall character of the stem is dominant over dwarf. By considering the homozygous tall with the genotype capital T, crossing it with the homozygous recessive character, that is dwarf small t, F1 hybrids are produced with heterozygous tall plants or hybrid tall plants with capital T, small t as the genotype. Okay, remember these words. Then you have to write this, not just only writing the cross, write this, whatever I am saying. Next, after the F1 plants are the F1 hybrids are self-pollinated or selfed, they produce the phenotype should be the hybrid tall and hybrid tall. Genotype should be capital T, small t, capital T, small t. Gametes, while producing gametes, the hybrids, because of the heterozygosity of the alleles show separation. They get segregated. Although in parents they were together without masking each other, the two alleles get separated or segregated. Therefore, it is stated as law of segregation. And the gametes are pure for their characters, so therefore it is called law of purity of gametes, because parents were not pure, they were hybrids. Now, the two gametes formed capital T small t in both the sides. You have to write the F2 generation explained using the Punnett's checkerboard. Write the checkerboard. One side male gametes, one side female gametes, and gametes must be circled even in P1 gametes, F1 gametes, even in the checkerboard. Write the circular gametes. Write the allele and circle that. Then put the checkerboard, big checkerboard, half a page, and write it thoroughly, and then write the phenotype and genotype of all the four combinations. At the end you write phenotypic ratio of F2 in a monohybrid cross is 3:1 and genotypic ratio is 1:2:1, because 3 tall to 1 dwarf is a phenotypic character, but capital T 1, capital T small t are 2, small t is 1, therefore it is 1:2:1. That's a monohybrid cross. Once you write, then only this whole explanation is completed. Right? Second question. What is a dihybrid cross? What is dihybrid cross? Okay. Explain law of independent assortment. Or second law of Mendel with an illustration. See, the same thing I am saying. This is a pakka question. 100% you will get this. Now, you have to write what is dihybrid cross. It is a cross between two pure breeding plants that differ in two pairs of contrasting character. Minimum. This is two dihybrid cross. During this, Mendel considered a double dominant parent. That means pure double dominant parent is obtained by making pure breeding for two important dominant characters in the same plant. So, double dominant parent is crossed with the double recessive parent. Better you consider the example of the seed only. In pea plants, you should write it. Write the description. In pea plants, the smooth seed coat, capital S is dominant over wrinkled seed coat, small s. Right? Now, when these two pure breeding plants are crossed, which are double dominant, right? Capital S, capital Y, crossed with small y, genotype, and we get the gametes. The gametes are showing law of independent assortment. So, what is independent assortment? When two pairs of contrasting characters are considered in dihybrid cross, each allele of an allelic pair independently assort with the other allele of other allelic pair independently. That is second law of Mendel. Then consider it and cross them. You get F1 hybrid, dihybrid F1 are undergoing self-pollination, then you get the different types of gametes. That is due to law of independent assortment. Then make a checkerboard in F2, form 16 combinations, and one side male gametes, one side female gametes, circle them. Write a bigger checkerboard, bigger squares, write the genotype and phenotype in each. Then at the end, you calculate how many are dominant. 9 will be dominant, 3 and 3 will be recombinants, 1 will be recessive. That's a 9:3:3:1 ratio. This is dihybrid cross. This you have to practice. Okay, that's the end of Mendelism. Then one more very important question in this is explain or define incomplete dominance and explain with an example. So this is what we explain at the end. That is, we have taken the 4 o'clock plant, crossed red and white, got the hybrid as pink, pink was selfed, and in F2 we get 1 red to 2 pink to 1 white. That is incomplete dominance. The deviation from Mendelism observed only in 4 o'clock plant or the Mirabilis jalapa plant. These 3 questions you always remember that they come from this chapter and they are perfect questions to write. Even with the description and the checkerboard. This checkerboard carries half marks, explanation carry half marks. Okay, so that's all about Mendelism, and practice this, and I will be observing how much you practice them and show me in your notebooks. Okay, see you then.